We're almost done with the margin utility section. There's still another concept to learn, and that's margin utility per dollar. Because sometimes we have so much money to spend, and we have a couple of different goods that we could buy. So how do we compare them? Well, we would have to find the margin utility per dollar to accurately compare those two items. So if we go back to the example of clams, and then we also add in another product, which is potatoes. And you can, again, see the utility for clams. We saw that in the slide a few slides back. And the margin utility column. Well, what if it costs $4 per pound of clams? Well, then we would have to take 15 divided by 4, 10 divided by 4, 6 divided by 4, 3 divided by 4, and 2 divided by 4. That will get you your marginal utility per dollar. So when you see the word per dollar, it means you're going to have to divide something. Potatoes, again, you can see the utility for potatoes and the margin utility of potatoes there. Margin utility, again, is the satisfaction of each additional potato. So you subtract the second potato from the first one, and that gives you your marginal utility. If it is $2 per pound for potatoes, you would divide that number then of margin utility by $2 to get your margin utility per dollar. You want to get the most bang for your buck. You want to maximize your utility. So when a consumer maximizes their utility, the margin utility per dollar spent must be the same for all the goods and services in the consumption bundle. This is why we need to find the margin utility per dollar so that we can see where they're equal and how much you should spend on each good. Why, you ask? Well, if Sammy's margin utility per dollar spent on clams is higher than his margin utility per dollar spent on potatoes, then he is consuming too many clams, and vice versa. He maximizes his utility if they are equal. You can see the diagram below. The marginal utility of clams over the per dollar of clams equals the margin utility of potatoes over the dollar price of potatoes. Then where they're equal is where the optimal consumption rule would be in effect. The next few slides deal with consumer surplus and producer surplus. This really isn't too hard of a concept. Let's say that you like to play video games and the new Call of Duty game came out. How much money would you be willing to spend on it? Some of you might not be willing to spend any money on it, but there's going to be one or two of you in the class that really likes this game and want to have it. You might be willing to spend, let's say, $80 on it the night that it comes out. So 80 bucks, you know, it's a lot, but I'd be willing to buy it. If it was that much, I would be willing to buy it. However, I don't have to pay $80 for it when I go to GameStop. It's only $50. So that gives me consumer surplus. So what would be my consumer surplus if it was worth $80 to me, but I only had to spend $50? Well, you're right. It'd be $30 in consumer surplus. Very simply stated, how much is the game worth to you, subtracted by how much you paid. On this slide is a demand curve for used textbooks. You'll be in this situation next year, I'm sure. Here's our potential buyers: Alicia, Brad, Claudia, Darren, and Edwina. And their willingness to pay. Alicia's willing to pay $59, Brad $45, then $35, $25, and $10. That's how much they're willing to buy a used textbooks for. So looking at the demand graph here, what happens if the textbook is $30? Not a bad deal, by the way. So if the textbook is $30, Alicia, who is willing to pay $59, now has a consumer surplus of $59 minus $30, which is $29 of consumer surplus. Brad also has consumer surplus of $45 minus $30, which is $15. And Claudia also has consumer surplus of $5. The other ones were not willing to pay that much for it, so they did not buy the good. For the total consumer surplus, we would just add up 29 plus 15 plus 5, which equals $49 of consumer surplus. Take a look at the graph below, and again, wherever the price is up to the top of the demand curve, that is where the consumer surplus is located. So you'll be asked to do that on tests, and it will come up in the next unit as well. So the total consumer surplus area is that triangle that's above the price up to the demand curve. There is also producer surplus. Producer surplus is simply the amount a seller is paid minus how much they would have been willing to sell the good for. Measures the benefit to all sellers participating in the market. Here is a supply curve for different producers. We have Engelbert, Donna, Carlos, Betty, and Andrew. And you can see how much they would be willing to sell their textbooks for. So Engelbert's willing to sell his for $45, Donna $35, Carlos $25, Betty $15, and Andrew $5 for their used. So if the price is $30 for the textbook, only Carlos, Betty, and Andrew will be the ones selling their textbook. For Engelbert and Donna, there just wasn't enough money for them to, it wasn't worth it for them to sell it. So Carlos, here you can see his consumer surplus of 30 minus 25, and Betty's producer surplus, and finally Andrew's producer surplus. So here's the producer surplus. You can see the supply curve. If the price is $5, then anything $5 and below to the supply line is the producer surplus. When looking at consumer producer surplus, I actually like this graph a little bit better than the last two graphs I've shown you on consumer and producer surplus. Here you have the supply curve and the demand curve, and you can see where equilibrium price is at. So the equilibrium price up to the demand curve is consumer surplus. The equilibrium price down to the bottom of the supply curve is the producer surplus. So for this instance, someone's willing to pay an awful lot at point A there for this good, but only has to pay the equilibrium price. That gives them a lot of consumer surplus. Same thing with producer surplus. Someone's willing to sell it pretty cheap at letter C there, but yet they get the equilibrium price for it. So that is a lot of producer surplus for them.